Hi students, welcome to my channel. So now in this video, I will discuss about conditional distribution function. So in the previous classes, we discussed about distribution function and density function and conditional probability. Now we are going to discuss about conditional distribution function. So now I am considering an event A, and that event A is defined as x less than or equal to x. So now the probability of x less than or equal to x by b for the given event b is called conditional distribution function, which is simply written as fx of x by b. Fx of x by b. So this is the conditional distribution function. So here the event a is this is one. So simply you can note this as probability of a by b, where a is given as x less than or equal to x divided by b for the given event b. So this is simply written as fx of x by b. So simply I can write this as fx of x by b is equal to probability of x less than or equal to x by b, and that is equal to probability of a by b means simply we have the formula probability of a by b is equal to probability of a intersection b probability of b. Similarly here also you can write this as x less than or equal to x intersection b divided by probability of b. Okay, so you can take this as a joint event of the two, x less than or equal to x intersection b as a joint event. Okay, and the joint event consists of all the outcomes of sample space S such that x of S is less than or equal to x and S is belongs to B. So this is the condition. Okay, and now the conditional distribution function applies to discrete and continuous or mixed random variable. So now I am taking fx of x by b is equal to sigma I is equal to 1 to n probability of x I by b u of x minus xi. So now I'm taking x as discrete random variable. Discrete random variable. Okay. And if you go for the properties of the conditional distribution function, you can take all the properties from simple distribution function. So as per the simple distribution function, the property is fx of minus infinity is equal to 0. Simply here also you can take fx of minus infinity divided by b is equal to 0. We have already discussed all the description about these conditions in the previous videos while discussing about the properties of distribution function. So you can apply the same for this also. So fx of infinity divided by b is equal to 1, and for the given condition you have to include conditional event. That's enough. So 0 less than or equal to fx of x by b less than or equal to 1, and fx of x1 by b less than fx of x2 by b if x1 is less than x2. And the fifth property, probability of x1 less than x less than x2 by b is equal to fx of x2 by b minus fx of x1 by b. So simply we have written that in the previous simple distribution function as fx of x2 minus fx of x1. So now since it is a conditional distribution function, we have to mention the given event also, that is fx of x2 by b minus fx of x1 by b. And the sixth one, fx of x plus with a small increment value, you have to take this as fx of x by b1. So these are the properties of conditional distribution function. And similarly, we will discuss about conditional density function. So now the conditional density function fx of x by b is the simple derivative of the distribution function, as we know already. So I have to take this one as like this. Okay. And for a discrete random variable, I can take this as fx of x by b sigma I is equal to 1 to n probability of x divided by b del of x minus xi for discrete random variable. So this is density function with the conditional event. So if you take the properties, the first property is fx of x by b is greater than or equal to 0. And second one is integral minus infinity to plus infinity fx of x by b dx is equal to 1. And third property, fx of x by b is equal to integral minus infinity to x fx of x by b dx. And the fourth property is probability of x1 less than x less than or equal to x2 by b is equal to integral x1 to x2 fx of x by b dx. So this is about the properties of conditional density function, and the description about all these four density function properties are discussed in the previous videos while discussing about simple density function. So you can take the same concept here also for the given event b. Okay, thank you for watching.